Hello, this is Amir Shahata with another quick tip for the LUTF. Now that we have a general understanding of what the LUTF is, how to build it, deploy it, and configure it, let's get our hands dirty and run it. There are three environment variables we need to set in order to run the LUTF. Luster, which is the base directory where the Luster tests are. LD library path, which should include the path for the LUTF shared libraries, and the LUTF path, which is the path to the LUTF binary. With these three environment variables, you can really put the LUTF in any directory and it should work. What I usually do is I add these environment variables in a bash file, say lutf.sh, and then source it when I first log in. Again, I'm explaining the LUTF from the ground up, so you'll realize a bit later that a method to set these environment variables automatically comes packaged with the LUTF. We'll cover that when we talk about how the LUTF integrates in the existing Lustre test infrastructure. For now, let's just start the LUTF manually and explore it a bit. Once you have the environment variables set, you will need to create a YAML configuration file to give to the LUTF on startup. We went over the YAML configuration file in a previous tutorial. For today, you can download a sample YAML configuration file for the agent and the master from the wiki page linked below. Alright, now we're ready to start the LUTF. And voila! Welcome to the LUTF. You can see since we're running in interactive mode, we now have an LUTF Python shell we can work with. Right off the bat, let's see what we can learn about our test setup. First of all, the LUTF gives us a simple way to look at all existing suites. By using suites.dump function, you get a list of suites. If you remember our naming convention we talked about last tutorial, here's where it comes in effect. The LUTF gathers all the suites in the Python tests directory. Say we add a new suite while the LUTF is up. We can reload the suites by using the reload function. This comes in handy while actively developing test cases. Second, we can see all the scripts under a specific suite. I'm going to use my sample suite for this demonstration. Again, by using the dump function, we can see all the scripts. While we're actively developing test scripts, it becomes immensely useful to reload the test scripts as we add more and more test cases. We don't want to keep exiting and restarting the LUTF whenever we make a change to a script or add a new one. We can also display a bunch of information about this node. There is a me variable available which gives us some information about the node we're running on. We can find out the name given to this node by the test setup. We can find out the host name of this node. We can find out the type of the LUTF instance. We can find out the listening port for this LUTF instance. We can find out the telnet port for this LUTF instance. We can also find out the interfaces which this node has. Why is all this interesting? Well, because a script can just access the me variable and get all the basic information it needs about a node in a very simple way. Not only can a script access the local me variable, but it can also access the remote me variable and get all the information it needs about the remote. The script will look exactly the same in both cases. This makes writing test scripts very straightforward, as we will see later on. Beside information about the local node, we can find out who's connected to us. You can do that by using the agent's dump function. You can see that it tells you the name of the LUTF instance connected and its type. In this case, we're the master and one agent is connected to us. I can run the exact same command on the agent and it will give us the corresponding information. This concludes our initial active tour of the LUTF. In the next tutorial, we'll start looking at how to write and run scripts.